This video introduces the Linux and FSP Quick Start on RZ T2H or RZ N2H evaluation board. It provides step-by-step instructions for building, preparation before use, and an overview of the bootloader and U-boot. Here are the abbreviations you will see in this video. In the first part, you will be introduced to an overview of what is needed for Linux startup. The user will need a Linux PC to build the board support package. A Windows PC can also be used as a serial terminal via T2H. The RZ T2H is equipped with two types of cores, Cortex-R and Cortex-A, for different applications. It includes a Cortex-A 55 core running at up to 1.2 GHz for Linux or general-purpose applications, and Cortex-R 52 core running at up to 1 GHz for real-time control using bare metal or FreeRTOS with FSP. Here are the required hardware for the Linux and FSP Quick Start on the RZ T2H evaluation board. Here are the operating systems used on the Linux PC and Windows PC. In the second part, you will learn how to set up the necessary software for startup. On a Linux PC, before building, you open the terminal and run the apt-get command with root privileges to update the package list and version information. Next, create a working directory in your home folder. Navigate to this directory in the terminal, then run the command to copy the Linux BSP package into it. After that, extract the package. The package can be downloaded from the Renesas website. To download the package, open your web browser and enter the link to download the Linux BSP package. Click the download icon to save the package to your computer. Before proceeding, make sure your build environment has at least 100 GB of free disk space to complete the process. After extracting the package, initialize the build environment in Pokey by running the oeinit build env script. Enter the template config command followed by the platform configuration path, then press Enter key. Next, enter the command to build the target file system image with bitbake, then press Enter key to start the build process. The image for RZ N2H evaluation board can also be built using a similar command. Just replace the board name from T2H to N2H. The process may take several hours, depending on system performance. After the building is successfully completed, a success message will be displayed in the terminal. Connect the RZ T2H evaluation board to the Windows PC via a USB Type-A to Mini-B cable through CN34 or CN26 in the case of the RZ N2H evaluation board. This allows the PC to act as a serial terminal using software like T2H. After that, open T2H, then go to File and select New Connection to begin setup. The COM port number may vary depending on the PC. To configure T2H, go to Setup, choose Serial Port and apply the following settings. Be sure to use 115,200 bps for the speed setting, other values may not work. In the third part, you will be introduced to step-by-step how to boot Linux on the evaluation board. Set the board to SCI download mode using SW14, as shown in the table, before turning on the power. This mode can also be set for the RZ N2H evaluation board using DSW3 with the same setting. This allows T2H to send two flash programmer images to RAM. Then turn on the power using SW16 on the RZ T2H evaluation board. For the RZ N2H evaluation board, use SW1. After powering on, a message will appear on the T2H screen indicating that the system has switched to SCI download mode. Next, send two flash programmer images using the T2H. These files are generated after building the image on a Linux PC. Start by dragging and dropping the HDR-NM file into the T2H window, then click OK button. After transferring the HDR-NM file, drop the Flash Programmer file into the T2H window and click OK button. Once completed, the Flash Programmer will start automatically and display a message in the T2H screen. Move to Boot step. Booting requires writing two bootloader files to the target board. The Flash programmer's xspiw command receives binary data via tera term screen and writes it to Flash ROM with main memory load info. Start by executing the xspiw command, which includes the necessary load address information. Then, when the send file message appears, send a file that begins with BL2 via tera term window. Once the binary is successfully downloaded, completion messages will appear on the terminal. If prompted to clear data, enter Y to proceed. Next, send FIP file from the tera term window when the send file message appears. Once the binary is downloaded successfully, a confirmation message will appear on the terminal, just like the first file. After both bootloader files are written, turn off the board's power switch on SW16. After the binary download completes, set SW14 to XSPI boot mode as shown in the table. Then, turn on the RZ T2H evaluation board by toggling SW16. Bootloader information will appear on the tera term screen. In case with board RZ N2H, user needs set DSW3 to XSPI boot mode, then turn on evaluation board by toggling SW1. After completing the bootloader writing process, we will move on to preparing the microSD card, which is required to boot the evaluation board. First, run the apt install command with root privileges to install the bmap tool. Bmap is a tool helps flash system images faster by only writing needed data. Next, insert the microSD card into your Linux PC. Then, run a command to check its device name. In this example, it is dev-sdb. Replace dev-sdb with your actual device name. Next, user need unmount the device before continuing. Finally, run the command to write the image onto the microSD card. Once done, the microSD card will be properly prepared for booting. Move to the next step, insert the microSD card into slot CN16 on the back of the board. For the RZ N2H evaluation board, insert the microSD card into slot CN22. After inserting the microSD card, power on the board to boot Linux. The user has now successfully booted Linux on the RZ T2H evaluation board. To stop the Linux kernel, run the shutdown command in the tera term screen. The shutdown sequence will start, and a message saying reboot, power down will appear on the tera term screen. Then, turn off the power switch SW16. In the fourth part, it shows to run a sample program combining Linux and real-time control using the FSP on eSquare Studio. Linux prints Hello World on the screen, while FSP controls a blinking LED. First, on the Linux side, user need to build the SDK, which includes cross-compilers, libraries, and development tools that allow the user to compile and test applications on the Linux PC before running them on the evaluation board. Return to the terminal directory and run the build command to start the process. For the RZ N2H evaluation board, users use a similar way but need to change T2H to N2H in the command. Navigate to the SDK directory and run the installer the .sh extension using sudo privileges. Proceed to set up the cross-compile environment. This setup must be done for each new login session. After setting up the cross-compile environment, user can build a Hello World application. Create a new folder, for example Hello World, then navigate into that folder. Create a file named main.c to print the message Hello World. After writing the content, press Ctrl+S to save, then Ctrl+X to exit. Create a make file to compile the main.c file, with an output name of user choice here, it's set as Linux Hello World. After writing the content, press Ctrl+S to save, then Ctrl+X to exit. After creating main.c and the make file, enter the command make in the terminal to start the build. Once the process finishes, an executable file named Linux Hello World will appear if the build is successful. To run the program, connect the microSD card to the Linux PC and copy the Linux Hello World file to user bin. Then, insert the card into slot CN16 on the RZ-T2H evaluation board. Now, the Linux side setup is complete. After building the Linux side application, create a LED blinking project using FSP in eSquare Studio. First, make sure eSquare Studio and RZ T2 FSP package are installed via the platform installer on GitHub. If eSquare Studio is already installed, just download the latest RZ T2 FSP package from Renesas. Extract it. Then copy the files to the eSquare Studio installation folder. Go to the internal folder and paste the copied files. To create a new LED blinking project, start by opening eSquare Studio. Click File from the menu, then select New. After that, move and select Renesas C++ project. In the next step, choose Renesas RZ as the target platform. In the eSquare Studio dialog, select Renesas RZ FSP project or Renesas RZ FSP project if user using the RZ N2H evaluation board. Then, click Next to proceed. Enter a name for the Blinky project. Then, click Next to proceed. Select the target device used on the board. For RZ-T2H, choose RZ-T2H evaluation board, RAM execute without flash memory, and RZ-N2H evaluation board, RAM execute without flash memory, for RZ-N2H evaluation board. Verify and select the FSP version, device, and core whether the user is using the RZ-T2H evaluation board or the RZ-N2H evaluation board. Keep the default settings as suggested and do not make any changes. Then, choose the debugger and required toolchains. Click Next to continue. No changes required on this screen. Keep default settings and click Next to proceed. As this is a Blinky project without RTOS, keep the default settings. Click Next to continue. In the Project Template dialog, select the Blinky template. Then click Finish to complete the project setup. Click the Configuration XML file in the project. Here, user can set up required drivers and project configurations. The example Blinky project code is preloaded. It's now ready for building and debugging. Build the project to check for any issues. If successful, a message appears in the Console tab. The LED blinking program is now ready. After building both the Linux and eSquare Studio programs, the user will now run them together. Launch TerraTerm and configure it using the previously specified settings. Power on the evaluation board to boot the Linux kernel on the RZ-T2H evaluation board. Next, load the program from eSquare Studio to the board. Click the debug icon and open Debug Configuration to set the required settings. On the Debug Configuration screen, set the following before flashing. Select User Project, set Debug Hardware to J-Link, ARM. Select Target Device as shown on the screen. Be cautious with the reset setting options. Enabling them may reset the device and cause malfunction. To avoid issues, set Reset at the beginning of connection, Reset at the end of connection, Reset before download, and Reset after download to no. Under Connection Setting, set CPSR, 5-bit, after download to Yes. Click Debug to flash the project to the board. After the debugging process starts, a screen will appear. Click the Switch button to proceed. Press F8 or click the icon to continue program execution. Press or click them again to continue. After execution, the LED on the board will blink indicating the FSP program is running. Next, on the Linux side, type root then type Linux Hello World in TerraTerm to display the Hello World message.